This is First Coast Math Clinic with Lesson 6, Square Roots, from Unit 10, Exponents, from our Pre-Algebra and Algebra curriculum. The goal in this video is to find the exact and approximate value of square roots. And before we get into square roots, I think it's going to be helpful just to review perfect squares, so what our perfect square values are. So let's review some of our more common perfect squares. So if we start with 2 squared, we're going to get 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and 13 squared is 169. And we remember that when we're squaring, so if we just take like 7 squared, for example, that 7 squared means 7 times 7, that exponent of 2 tells us how many times you multiply that base by itself, and that's going to give us 49. So the perfect squares or squaring is going to help us when we're finding our square roots. So if we're finding our square root, looking at our square root, so our square root symbol looks like this, and this is, it's called a radical symbol. And then I'll just put an n inside that radical, and the value, whatever value is in the radical symbol, is known as the radicand. And when we're finding the square root, we're basically asking what numbers, when multiplied by itself, is equal to the radicand. So for example, let's say we're asking for the square root of 4, okay? We're saying, well, what number times itself is 4? So let's kind of look at our perfect squares and work backwards and say, well, we've got our perfect square here of 4. What are we multiplying by itself to get 4? That 2. So our value has to be, well, we know 2 times 2 is going to give us 4. So one of our answers has to be 2. But let's go a step further and say, okay, well, is there anything else we can multiply by itself and get 4? Well, what if I multiply negative 2 times negative 2? I'm also going to get positive 4. So our answer is going to also be negative 2. So the way we're going to write our answer, since we've got a positive 2 and a negative 2, we're going to write our answer as positive and negative 2. Okay? So our square root of 4 will be written as positive negative 2, because both positive 2 times positive 2 is going to give us positive 4, and negative 2 times negative 2 is going to give us positive 4. All right, let's get into a couple examples where we find our square roots, and then we'll get into some more complex examples where we have to break apart our square roots a little bit, and then work with some examples or equations where we have to kind of solve an equation and solve for x involving a square root. So let's get into some basic examples. Okay, so for examples 1 through 4, we want to find the exact square root. And for number 1, we've got the square root of 9. So our radicand here is 9. So we're basically saying, well, what number times itself is 9? And from our perfect square table on the previous slide, we know that, well, if I took 3, squared it, we got 9. So we know that 3 times 3 is equal to 9. So one of our answers is going to be positive 3. But let's go a step further, right? We also know that, well, if I take negative 3 times negative 3, we're also going to get positive 9. So let's add in a negative answer. So our answer is going to be negative 3 as well. So we're going to have positive 3 and negative 3. Here we've got the square root of 16. So our radicand here is 16. From the previous slide, we said that 4 squared is equal to 16. So that tells us that 4 times 4 is equal to 16. So we know that our square root is going to be a positive 4, right? But we can go a step further, and we know that negative 4 times negative 4 is also going to be positive 16. All right, so we're going to add in our negative answer. Number 3, our radicand is 49. So from the previous slide, we looked at our table of perfect squares. We know that 7 squared is 49. So 7 times 7 is 49. So our answer here is positive 7. But again, let's go another step. So negative 7 times negative 7 is also 49. So let's add in our negative answer. And our last one, square root of 25. Well, we know that negative 5 squared is 25. So that means 5 times 5 is 25. So our answer is positive 5. But we could also add in the negative answer because negative 5 times negative 5 is also positive 25. So our answers here, positive and negative 3 for number 1, positive and negative 4 for number 2, positive and negative 7 for number 3, and positive and negative 5 for number 4. Okay, so for number 5, we want to find the exact square root of the square root of 12. So our radicand here is 12, and maybe thinking back, well, from that perfect square table on the first slide, well, we had we know like 3 squared is 9, and then 4 squared is 16. Well, we kind of skipped over 12. 12 wasn't on that table, so 12 is not a perfect square. So how are we going to figure this out? So there's 2 ways we could do this. First way is we could plug this value into our calculator, and if we plug it into our calculator, we're going to get approximately like 3.46410, and it's going to keep going on from there. I'll round that 2 because it's 1/6. But once I do that, I'm rounding, and once I round, I'm not finding an exact value anymore. This is going to be an approximate. So we've rounded, and I could do it, but I could do a little better than that, right? So we don't want the approximate, we want the exact. So here's how we're going to find the exact value, the exact square root for that square root of 12, okay? Without plugging this into our calculator. Here's what we're going to do. So we've got our square root of 12, and we know that, well, we could factor 12, and we could take 12 and factor it into the product of 2 square roots. And we know 12 is the product of 4 and 3. So if I multiply 4 times 3, I'm going to get back that 12. Well, if I'm looking at the 4, I notice, well, 4 in particular is a very specific type of number. 4 is a perfect square, right? So we know our square root of 4 is going to give us, from the previous example, positive and negative 2. So we can take the square root of this 4 and replace it with positive and negative 2. Now, square root of 3, not a perfect square. We can't factor it. Best we could do is 1 and 3. We can't do a whole lot with that, so we're just going to leave it the square root of 3. So our answer, the best we could do here is leave it as positive and negative 2 times square root of 3, and that's going to be our answer. That's going to be our exact square root. Okay, let's do a couple more examples where you find the exact square root for values that are not perfect squares. All right, so for number 6, we've got the square root of 18. So 18 is not a perfect square as well, but we know we can factor 18 into a perfect square. So square root of 9 times square root of 2. Okay, we know the square root of 9 is going to be, from the previous example that we did, square root of 9 is going to be positive and negative square root of 3. Actually, I'm sorry. just 3, positive and negative 3. Now that square root of 2, I can't factor it. I can't take the square root of 2, so I'm just going to leave it as square root of 2. So my answer here is going to be positive and negative 3, square root of 2. Now, you may be saying to yourself, well, we can factor that 18 into other terms, can't we, right? We could also factor it into 6, square root of 6 times square root of 3. All right, you can, but you don't have any perfect squares here, so we may have to do some more factoring. We could factor the 6 again into square root of 2 times square root of 3 times square root of 3, and we may have to multiply the square root of 3, square root of 3, and we're going to get back square root of 2 times square root of 9, which is what we had up here. All right, so our goal is to get the largest perfect square that's a factor of our radicand. All right, so once we do this, we get the square root of 9. We know that square root of 9 is going to be plus or minus 3. So I'll put that in front. Square root of 2, I can't do anything with. All right, 2, I can factor into 2 and 1. I can't take the square root of it. Factoring doesn't help me. Taking the square root and getting some ugly decimal doesn't help me. I don't want to do that, so I'm just going to leave it square root of 2. Okay, so both ways, I get the same answer, plus or minus 3 times square root of 2, whether I factored it into square root of 6 times square root of 3, or square root of 9 times square root of 2. Finding that largest perfect square, square root of 9, first helps, shortens our steps. Right here we only had really like one step compared to like 1, 2, 3 steps, and then the last step. Okay, let's do one more example where we have to find the exact square root given a radicand that's not a perfect square. For number 7, we have the square root of 80. So our largest perfect square is going to be 16. So we can break this up into square root of 16 times square root of 5. Square root of 16, we know that's going to be positive and negative 4. And I can't do anything with that square root of 5. So that square root of 5 is going to stay as it is. So it just stays square root of 5. So my answer here is going to be positive and negative 4 times square root of 5. Okay, so that's the easiest way to do it. If you identify the square root of 16 right away, you're going to have the least amount of steps to do. But all right, what if you do this a little bit differently? What if you just say, all right, well, I know it's going to be square root of 20 times square root of 4. Okay, so we got that. Square root of 4, we know that's going to be positive and negative 2. So let's take that out. Positive and negative 2 times square root of 20. Okay. Now we could break up that 20 a bit further. So positive and negative 2. And square root of 20, we could break that up into, again, square root of 4, square root of 5. Square root of 4, again, is going to be positive and negative 2. So we're going to have positive and negative 2 times positive and negative 2 times, again, can't do anything with that square root of 5. So we're going to multiply our 2's. Positive and negative 2 times positive and negative 2 is just going to give me positive and negative 4. Can't do anything with the square root of 5, so we're just going to keep square root of 5, and that's going to be our answer. Okay. So again, finding that largest perfect square, square root of 16, gives us the fewest amount of steps, but if you start with 20 and 4, that'll work as well. All right, let's get into some examples where we have to solve equations and work equations into our square roots. Okay, so for numbers 8 and 9, we've got x squared equals 4 and y squared equals 64. And you're going to see this application a lot when you get into right triangles, when you get into Pythagorean theorem, solving for variables that are raised to the second power. So let's think of, we want to kind of undo this squaring. So let's think of our inverse operations, right? So for addition, our inverse is subtraction. For multiplication, inverse is division. For squaring, all right, for squaring, what's the inverse? What operation undoes squaring? Well, that's going to be square root. Okay, so if I'm squaring x squared, to undo squaring, I want to take the square root and square root of both sides. So the square root of x squared cancels out, so I'm going to be left with x equals the square root of 4. And we know that the square root of 4 is going to be, like we said in the last couple slides, positive and negative 2. And for number 9, y squared equals 64. Let's undo squaring and take the square root, take the square root. Square root and square cancel each other out, so we're left with just y equals, and the square root of 64 is going to be positive and negative 8. Now, if this was a Pythagorean theorem question, we'd have to interpret this answer a little bit more, but since we're just solving for x or solving for y, this answer would be fine. Let's get into one more example where we're solving for x and y. All right, actually, let's do 2 more. So I've got 2z squared equals 18. So thinking of our order of operations, right? We want to do exponents first and then multiplication. But when I'm solving for my variable, all right, let's go the opposite direction or opposite order. So I want to get rid of this 2 first. So I want to undo multiplication. So let's divide by 2. Divide by 2. So the 2's cancel out. I get z squared equals 9. Let's undo squaring z. So take the square root and square root. And then z squared equals square root of 9 is going to be positive and negative 3. And then number 11, let's get that y squared by itself. So I'm going to divide by 3. Divide by 3. 3's cancel out on the left. So I get y squared equals 27. Take the square root and square root. Well, that 27 is not a perfect square. So I'll get y equals, let's factor 27. So I could factor 27 into square root of 9 times square root of 3, because 9 times 3 gives me 27. And we know that the square root of 9 is going to give me positive and negative 3. Square root of 3, 3 is not a perfect square. Factoring 3 into 1 and 3 doesn't help me, so I can't really do anything with that square root of 3, so I'm just going to keep it square root of 3. So my answer is going to be y equals positive and negative 3 square root of 3, and that's going to be my answer for number 11. Okay. All right, so this video was lesson 6, square roots, from our exponents unit. If you like this video, leave a like, comment, and subscribe. I hope these videos are helping you guys. If you want to see some additional topics, videos for additional topics, just leave them in the comments. First goes math class.